Hi guys, I hope you are fine. Me too, I'm fine. And so guys, we come yet to another lesson on standard or normal distributed graphs. That is for probability. And so guys, we come and look at this question. So let me read it first and then we solve it. The question reads, the lifespan of 1800 light bulbs is normally distributed with a mean and standard deviation of that and that, respectively. Determine the number of light bulbs with a lifespan of more than 1200 hours. So the first thing guys, we come and use this graph. This one we are going to use it for normal distribution, and this one is not standardized. So I'll use this one for the one that is not standardized. So we have the mean of 900. And we have the standard deviation. This is the mean. Can write here as the mean. And you have the standard deviation as 150, like that. Determine the number of light bulbs with a lifespan of more than 1200 hours. So the 1200 is at this point. So let me call it, this one is 1200. And what we want guys is this is what we are looking for. But now guys, we can't use this because this is not the standard form. So we will have now to convert this into standard form. And how do we convert it? We convert it by this method. We say Z is equal to, that is X, which is 1200, minus the mean, which is 900. Now we divide that by the standard deviation. So this one is now going to give us 300, 1200 minus, hey guys, sorry for I have closed, you have not been able to see it clear, but now I have brought it to your eyes. And maybe I can repeat it again. We have said that the mean is at this point, that is 900. We have the standard deviation, I have written down it down here. And then we have what is required. We are told the number of light bulbs that have more than 1200 hours. So I have come and located my 1200 to be at this point. And what we are required is this. But now guys, because this is not the standard form, we have to convert this 1200 to standard form. And this is how we do it. We have the equation like this. Z is equals to, now X, the required value to be standardized, minus the mean all over the standard deviation. So that is the equation I'm using. So here we shall now have 300 all over 150. When without using the calculator, that is going to give us 2. And so in this, now the standard form, we usually have 0 here. And so we expect our 2 to be somewhere here. So now guys, we are going to go to our tables. And whatever we are going to find in our tables is actually going to be this. But now our requirement is actually this. This is what we require. This point is what we require. So we will have to take away from 0.5 for us to get this. So let's go to the table. Now for 2, that is Z being 2, we shall have, looking at the table, let me just bring the table close. So our Z is 2. So this is our 2 guys. Here, this is the 2. I hope you can see it clearly. That is 0.4772. So that is our value, 0.4772. 0.4772. That is our area. And this area is actually this. But what we require, guys, is this small area. So we'll have to take away from now 0.5, because remember, this is divided by half. The whole of it is 1. So this side is 0.5, this is also 0.5. So for us to get the required, we shall come and say 0.50. You take away now 0.4772, like that. So this one will now give us 8. This is 8. Here we have 1. Then 9 again, we have 2. It's not, yes, this is 2. This is supposed to be 2. And this is also supposed to be 2. And this is supposed now to be 0. Like that. So this one we say the ones that are more than bulbs, more than, that is lifespan, more with lifespan more than 1200 hours are now going to be, now we are going to have 0.228. You multiply by the number of bulbs, and the number of bulbs is actually 1800. So this one will give us, multiply that by use of calculator, we shall have 0.228 multiplied by 1800. So that gives us 410.4, meaning it is 411 light bulbs, like that. So we have 411. So guys, that is how we get our first question. So now let's go to the next one. We are talking of those between 600 and 1050. So we still come to our graph yet again, guys. We now come and establish, this is our normal. We have the 900 is there. And then we have what we are saying, 600. 600 is somewhere there. And then we have 1050 somewhere there. For this one is actually straightforward, because what we need is this. But now we are using this, we have to convert 600 into standard form and 1050. So that when we now come here, we shall have the 600 converted to Z and the 1050 converted to Z, and then we can check at both Z1 and Z2. So for Z1, let's say this one is Z1 at this point, and this one we call it Z2. So the Z1 is going to be equal to, we use 600 minus the mean all over. Now we write the standard deviation, which is 150. So this, guys, is going to be negative 300 all over 150. And so here, guys, we get 2. But remember, guys, though the 2 is negative, it will still be like this other 2. So there is no difference. It's only that this one was positive. This one is now negative. But we'll get the same 0.4772, only that it is in the negative side. So this one we shall get, this now will be equal to 0.4772. So that's what we are going to get, guys. Because in our tables we don't have negative, we only have positive. So even when we get negative, we get that. So this is now going, when we divide 300 over 150, we get 2, negative 2. So the negative 2 is right here. So when we now go to the tables, because we already had a 2 here, guys, and we were able to find this as our probability space, it will still be the same, only that now it is in the negative side. Instead of being on this side, now it's going to be on this side. So this one now, guys, is going to be, now from the tables, because we had already checked on 2, this one is now going to be 0.4772, like that, of which I have already written here. So the next thing, guys, is we look for Z2. For Z2, we apply the same principle here. 6, now it is going to be 1050 minus 900 all over 150. So whatever we get is now going to be our Z2. So that is going to be from the calculator 1050 minus 900 equals to that divided by 150. So guys, we get 1. And so after getting 1, now that we had not looked for 1, we need to go to the table and look for it. This is 1. So when we go to the table, we are going to get this area now. And so we look at this table and look where we have our 1. Our 1 is right here. So this one, let me show you clearly. This is our 1 right here. And this one gives us 0.3413. 0.3413. Maybe I can show you in a better way. This is 1 and it is this one, 0.3413. Yes, 0.3413. So this one gives us 0.3413, like that. And so guys, we can write it here, 0.3413. And this is the probability, guys, we require between Z1 and Z2. So we come and now add them together. So we shall have 0.4772 plus 0.3413. So this one gives us now 5 there, we have 8 there, then we have 1, then we have 8 there, and we have 0 there. So this is our probability. And so we now come and multiply that probability with the number of items, or so to say, the light bulbs. And the light bulbs are actually 1800. So let's see the number of light bulbs that are in between those values. That is 610.50 hours. So now we shall do that multiplication, and this is what we shall get. And this is what we want to find out. So this one will be, I can do it all just here. Even if you don't see, I'll tell you. 0.8185 times 1800. Sorry, 100. That is equal to, that is supposed to be, let me see, that is 1,473. 1,473.3. So we can write 1474. Because if there is something more, it means it's another verb. And so guys, that is how we do that problem. So thank you guys. These are verbs. So thank you guys for listening to me. Bye bye.